start off with changing the background color to dark and adjust the project frame range. Create a test geometry crag. Let's remove the hammer and the shader. Use a time shift node to freeze the animation to the start frame. Use a convert node to convert crag back into regular polygons. Through a few lines of vex, we can convert the position into UV space, which we will use to project curves onto crag. We can see this generates a huge mess. To fix this, we first have to separate the vertices from each other by their UV seams. We can use the vertex split node to do this. Let's reverse the geometry and recalculate the normals to have it display correctly. For the trail shapes, I start off with a point generate node set to 50. I then create a circle which I will copy on top of these points. Set the circle to be an open arc. I also changed the orientation to align the circle to the geometry we laid out in UV space. After copying the circle to the points, I create a p-scale attribute based on the point number. To make the circles a bit smoother, I use a resample node set to 0.0025 and subdivision curves. I then use a match size node to transform and scale the curves so they align to the crag geometry. We can see that some pieces of the crag geometry are not covered by the curves. To fix this, I use a transform node and scale the curves so every piece is covered. I use the labs thicken node to give the crag geometry some thickness. This will be used to perform a Boolean operation on the curves. To do this, we can use the labs Boolean curve node set to intersect. I also use the labs delete small parts node set to perimeter to delete all the very short curves. We can see we are only left with the curves that actually intersect with the crag geometry. I went back and changed the resample node to have a length of 0.005. I then use a UV texture node to create a curve view attribute. This attribute will be used to create a bunch of animations along the curve. I start off by fetching the U component of that UV attribute we just created. I then use that to create a looping animation with a random offset for each curve. This is then output into the alpha attribute. I multiply the alpha with a ramp based on the curve view to get a smoother fall off towards the end. The p-scale attribute, which will be the width of the curves at render time, is also based off of this alpha attribute. The result are a bunch of curves existing in UV space animating at random speeds. To create the curve colors, I will use a point swap. Create a ramp from a random value based on the primitive number. Then multiply the color with 2. Go ahead and give the ramp some blue colors. Before we project the curves onto our geometry, let's go ahead and fetch the moving crag. Create a point wrangle node with the curves in the first input and the moving crag geometry in the second input. I use the UV sample function to project the curves back onto our moving geometry. I then went ahead and offset the animation a bit, and I also use a time blend node for REDSHIFT motion blur. At the end I use an output node. To properly render this in REDSHIFT, make sure to check the subframe motion blur in the instancing tab of the Geo node. Also make sure you enable the render as strands option. The material is really simple. Just bring in the color attribute with a point attribute node and plug it into the emission color. Turn off everything else in the shader. And we can also bring in the alpha attribute and multiply the color with that. I also connect the alpha to the opacity channel of the shader. Make sure to assign the material to the geometry node. I create a camera and we can go ahead and briefly talk about some render settings. Make sure you enable motion blur in the advanced tab of the REDSHIFT node. You can turn off the global illumination. And let's just render this using the automatic sampling. I usually render at 32 bits float. And what I usually do with these type of all emissive render passes is to render them at double the camera resolution. So I would usually do this for any type of particle effect or curve-based effect. If you are using REDSHIFT and don't want to go into a separate compositing software, you can mess around with the REDSHIFT post-process filters in the REDSHIFT render view. Here I'm just applying a slight glow. Thank you so much for watching, and I just want to mention that all of the files, including the nuke script and the full Houdini render setup, are available for free in the video description below.